Hello everyone, so the given problem says, consider the differential equation dy over dx is equal to negative xy squared over 2. Let y equals to f of x be the particular solution to this differential equation with the initial condition f of negative 1 equals 2. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. So as you can tell, I've already sketched out the slopes for the other points, but let's go ahead and do the other ones. So in order to find the slopes, all we have to do is plug in the x and y coordinate into the differential equation here. So if we have negative 1, 1, all we have to do is plug it in. So negative 1, y is 1 squared over 2. The negative and the negative will create a positive, and we will be left with a slope of 1/2. Now for negative 1, 2, we plug it in, we have negative 1, 2 squared over 2. Again, the negative and the negative will turn into a positive, leaving us with 4 over 2, or so after you're done finding your slopes, you're gonna have a table at the end. So for the points that we haven't done, negative 1, 1 and negative 1, 2, we'll just draw out our slopes. So for negative 1, 1, we got 1/2. So it should look like that. And then for negative 1, 2, we got 2. So that will look like something like this. A good trick to keep in mind is rise over run. But that's how you draw out your slope field. B states, write an equation for the line tangent to the graph of f at x is equal to negative 1. So in the beginning, it states f of negative 1 is equal to 2. So let's write that over here. Okay, so while we have those points in, we can plug that into the point slope form. So y minus 2 is equal to, and this is your slope, parentheses x plus 1. We need to find our slope, but we've already sketched out the slope field. So for the point negative 1, 2, we got over here 2. So that would be our slope. So if we were to simplify that, and that 2, that would be our equation for the line tangent to the graph of f at x is equal to negative 1. C says, find the solution y equals to f of x to the given differential equation with the initial condition f of negative 1 is equal to 2. Alright, so what we would do is we would simplify the differential equation. By doing that, I would cross multiply, get 2 dy equal to negative xy squared times dx, and then I would divide this by negative y squared on both sides. So I put that on negative y squared, that cancel out these ones, and then negative y squared. Okay, and then afterwards you would want to simplify that, and so you would get negative 2 y in parentheses negative 2 dy is equal to x of dx. Now let's find the antiderivative of that. So we would get x squared over 2 plus c is equal to 2y negative 1. And to make sure of that, if you find the derivative of this, then you should get x. So it would be 2x over 2. That would just be x. Okay, that's correct. And then you would find the derivative of this, and so it would give you negative 2y negative 2. Okay, that's correct. Now we need to solve for c. And so the initial condition that we were given, f of -1 is equal to 2. We plug that into these points and we will solve for c. So let's just simplify this. So y is on the bottom, x squared over 2 plus c. Now 2 over y is equal to 2. X is equal to -1 plus c. You are left with 1 is equal to 1/2 plus c. And you'd be left with c equaling to 1/2. Alright, so now that we have c, let's create a little section over here. Let's plug it in back into this so that we can find our solution. So we have 2 over y is equals to x squared over 2 plus c. But we already solved for c, so c is equal to 1/2. Oh. Alright, so we have a 2 over here, but we want to have y alone. So since we want y alone, we would multiply both sides by 1/2 so that it would cancel on this side. So if we were to multiply it by 1/2, this would cancel on that side, and we would multiply that, and we should get x squared plus 1 over 4 because they have a common denominator. And then on this side we'd have 1 over y. So since it's just 1 over y, we can just flip everything, and we should get y equals to 4x squared plus 1, and that's your given differential equation.